A study was done on smoking and lung capacity. 200 smokers took part in a study that asked them how many cigarettes a day they smoked and then measured their lung capacity. The correlation was found to be R is negative 0.992. Based solely on this study, it can be concluded that smoking causes lung cancer. Now, let's be careful here. What does this R show us? It's negative 0.992, right? So that means the dots on this study are going down pretty much in line. Here, let me put them over here. These dots are going down pretty much in line, aren't they? R is negative 0.992. That's almost straight down line, which means what? What are we talking about? This is number of cigarettes they smoke daily and their lung capacity, like how much air they can hold in their lungs. So it's basically showing that the more cigarettes they smoke as you go up, right? Like smoke 10 a day, 20 a day, 30 a day, the more their lung capacity, I don't know what numbers are, maybe you can hold 10 cubic centimeters or 20, 30, 40, I have no idea what the numbers are, but it looks like it's going down. The dots are going, how do I know they're going down? It's negative. So it must be going down, and it's almost a perfect line. So it's going down. So that means more cigarettes per day, lower lung capacity. More cigarettes per day, lower lung, see this goes down to the right, lower lung capacity. So based solely on this study, it can be concluded that smoking causes lung cancer. More cigarettes, less lung capacity. Smoking causes lung cancer. Is that true? Well, it turns out that is true, but not because of this study. It's false based on this study. This is a trick question. So what's the trick? It says, first off, based solely on this study. Why do they say that? Because there are other studies which provide strong statistical evidence that smoking causes lung cancer. There's other studies, but this is not good enough. That's the point of this question. If you have this data alone, this is false. It's not enough. Why not? Why not? I mean, it's more cigarettes, less lung capacity. That proves it, right? No. Here's the key word, causes. This study only shows a connection between smoking and lung capacities. You got to be careful. This is really important in real life. People will try to say that one thing proves another, and you got to be more careful than that. This study only shows a connection between study. It does not. Let me change my color here. It does not prove causation. It does not prove causation. So remember, I don't know if you remember, back in the very beginning of the course, chapter 1, I gave you an important phrase. Correlation is not causation. That's probably, if I was to pick one thing that's most important in this class, it's that you get that sentence alone. It's huge. It'll for sure be on the final exam. It was back in our first exam. And it's what they're testing on this question. Correlation is not causation. Just because two things are connected, definitely this graph proves that there's a connection. This study does show a connection, but it does not prove causation. What are you talking about, Heron? What do you mean? Well, because there's things in real life that are connected that are not, one is not causing the other. So for example, if I looked at the temperature outside day by day by day, right, throughout the months of the year, and I said the days, and I said, hey, look, I noticed something on a graph. What I did is I graphed the temperature, the high temperature on various days, and the number of drownings. Wait. Oh, I'm sorry. I'm not doing this right. The ice cream sales. Ice cream sales. So in my city, I let me show you an example where something does not causation. If you were to study ice cream sales in your city, right? Ice cream sales in the city, and the number of drownings in your, let's say for the whole state of California, right? So we would find a positive, a very, very much a positive correlation. The line would go up, positive correlation, meaning days in which there's more ice cream sales in the city, there tends to be more drownings. People drown. But ice cream sales are not causing drownings. Of course, that'd be silly. Not causation. What's happening there? Why is there a connection, but not a causation, between ice cream sales and the number of drownings in the state of California? Why in July and August and September every year are there more ice cream sales and there's more drownings? Why would that happen? In July, August, and September. That's the summer, right? In the summer, people buy ice cream much more often than they do in the winter or fall. And also, there's more drownings because it's hot. People buy ice cream, people swim, some people sadly drown, right? But we know ice cream sales are not causing drownings. We got to stop selling ice cream. It's causing people to drown. No, that'd be crazy. Well, but we did a graph, and then the dots went up, up, up. They're in a very linear relationship. So ice cream sales is connected to drownings. Yes, it's correlated. It's connected, but that doesn't mean one thing is necessarily causing the other. It's not causation. It's correlation. And correlation is not causation. Not necessarily. Now, in the case of cigarettes, it definitely is, right? So do you hear what I'm saying? I'm just saying you need more data than just that. You need more data than just that. Two things can be connected without one causing the other, like ice cream sales and drownings. One may be causing the other, and it may not. You need more evidence. What kind of evidence? And the same thing goes down here for the CO2 levels, right? Let's just do number 13 at the same time. This one's going to be false for the very same reason. They're saying the study of CO2 concentration, the global found, there it is. Based on this correlation, it can be concluded that increased levels is causing. Now, it very well may be. And there may be other data that shows that. But just a correlation, a dot chart, a scatter plot it's called, is not enough to prove causation. These are both false for the same reason. You need anything. Well, how do you prove anything then, Heron? How do you prove anything? Well, you've got to do a different kind of study than just looking if the dots are connected. You've got to do an experiment. What do I mean by an experiment? Where you have one group, like you'd have to have one group of random people who smoke and another group of random people who don't smoke. And at the end of, and then after 10 years or whatever, a decade, then measure their lung capacity. So you have to randomly choose two different groups. You can't let it be, it's a longer story. You can't let it be people who choose to smoke or not smoke on their own. That sounds funny to say, but you have to choose it for them, because otherwise, if you let them choose, these are, people that are choosing to smoke are also choosing maybe some other harmful things to their life, which are actually what's harming them and not the smoking. So you see, you have to weed all that out by doing what's called a random experiment, where you take a group of people and you say, okay, I want you guys to smoke for the next 10 years, and I want you guys to not. You choose for them, so you get rid of all the other strange stuff that might come along with choosing on your own to smoke or not smoke. And then if at the end of the 10 years, there's a difference between the random group that you had smoke and the random group that you didn't have smoke, then any differences can be attributed to the smoking, because that's the only difference between the groups. So it's a little more complex. And I refer you back to chapter 1, where I talked in more detail about that. I gave the Boy Scouts example. I gave the bottled water countries in, people in the world that have never had bottled water die of cancer less often. I gave those examples in which I explained in more detail the difference between an experiment in which you randomly picked. I think I did tutoring as well. I said, what if you have a group that does tutoring, does better in the test versus another group that doesn't? So I refer you to that kind of studies back in chapter 1 about that kind of stuff, right? The tutoring one is actually, makes me want to say a word about tutoring. It's actually an excellent example. What if you had a bunch of people and you some people, what if some people went to tutoring on their own choice, their own free will, they chose, and their grades came out higher than the students in class who did not go to tutoring. So what if you did that? What if some people went to tutoring on their own choice, and the grades were higher? Their grades, I'll say their grades were higher than the students in class who did not choose to go to tutoring. Does this prove tutoring causes higher grades? Oops, sorry, I'm running out of room here. No, this doesn't. Why not? The ones who went to tutoring got higher grades. This is, again, correlation is not necessarily causation. What do I mean? I mean this. People that go to tutoring, right? They chose on their own choice. People who choose to go to tutoring on their own likely, probably, also study harder on their own, right? The kind of people that choose to go to tutoring are probably the kind of people who are just going to study harder in general. So maybe it's not the tutoring. The tutoring might be lousy. And it's just the fact that these happen to be harder working students. They have more time. They don't have as many jobs, and they don't have as many kids, and they're just going to give their all to the class and study night and day, and they're doing tutoring and they're doing everything in the world. Yeah, they're going to get higher grades, but it doesn't prove that the tutoring did it. Do you see the problem? Now, you think, well, how do you ever prove anything? So let me again answer that question. To prove, here's how you would have to prove it. To prove tutoring causes higher grades, what would you have to do? You would have to do an experiment. Experiments. Remember when we studied experiments? It's good to remind you of this again, where you have group number one. Well, let me say experiment, which you take 100 people, 50 at random, chosen at random. It can't be their free choice. Chosen at random to go to tutoring. Not their free will choice. So it's not their free will choice, right? You're just getting 50 people at random, and then 50 at random to not have tutoring, right? They might have been people, some of them, that wanted to go to tutoring, but you're not going to allow them, which sounds kind of weird. You are not allowed to go to tutoring. But that's how you get to the truth. You see, if you just took 100 people and 50 at random to go to tutoring, not their choice, you assign them at random. You flipped a coin or whatever. And then 50 other ones you chose at random. That random is so important to not go to tutoring. Then there's no difference between the groups. You see why this helps you get to the truth? Then there is no difference between the two groups. There's no difference between the two groups, right? Whereas if you just let people choose to go to, say, okay, who wants to go to tutoring and who doesn't? Well, that there's a huge difference between the people that choose to go to tutoring on their own free will and the people that don't, right? That's going to make a big, there's going to be a lot more different about those people than just they went to tutoring. They're going to probably be harder working students in general. And so then it's all mixed in, and you don't know if it was the tutoring or if it was the fact that they were just harder workers or what it was that made them do better. Whereas if you take 100 people and 50 at random, you decide they go to tutoring, not they decide, and 50 at random to not go to tutoring, you decide they don't decide, then there's no difference between the two groups, except the tutoring. That's now the only difference between the groups. So if there's a different result, it must be because of tutoring. So different outcome, different grades must be due to tutoring, because that's now the only difference between the groups. Do you see? That's an experiment. Do you feel the truth of how that gets to the truth? That's the only way to really figure out with strong confidence if one thing is causing another. You have to have two random groups, right? And we call this other group the control group, because they help us control the experiment, meaning they did not get the tutoring. So they're just regular people without the tutoring. So they help us compare and give control of the experiment. So we know that the only difference is tutoring. We took control instead of there being a million things that are different about people that choose tutoring on their own. We've controlled out all those other factors, and the only difference is tutoring, because they're 50. They're two random groups of 50. So everything else is going to be mixed in. Some are going to be better students. Some are some are weaker, some have more jobs and more hours at work, some have more kids, less kids. That's all just going to be random in both groups. There'll be no difference. There'll be some in each group that have a lot of kids or no kids, or a lot of time or no time, a lot of jobs, no jobs, whatever. It's going to be all random, except 50 to tutoring and 50 without. So that'll be the only difference. There's no other difference. You controlled out all the other differences. So any different grades must be due then to tutoring, because that's the only difference between the groups. At that point, you can say there is statistical evidence that the tutoring caused people to do better. That's how you can, that's real statistical evidence, not just, hey, we saw some data, more cigarettes, lower lung capacity, more CO2, and more global warming. Well, maybe, but you have to do the studies more carefully than that. And that's probably the biggest mistake you see in common media, is they'll do correlation and they'll tell you it's causation. Not so simply. Just like the ice cream and the drownings. Use that with any of your friends who are thinking correlation is causation. Remind them that if you took the state of California, in the months that have more ice cream sales, in those months there's more drownings. But we all know that ice cream sales is not causing drownings. They are connected by higher temperatures, not causation, right? So just because two things are connected doesn't mean one is necessarily causing the other. Correlation does not necessarily mean causation. You got to be more careful. How do you be more careful? You do what's called an experiment. That's how you be more careful. And you have two random groups where you control all other differences by randomness, so that there's only one thing different, the tutoring or the smoking or the CO2. And then any differences must be due to that one thing that was different between the two groups.